All right, on Friday we worked on mapping congruent triangles. So we took one triangle and either rotated it, reflected it, or translated it onto a congruent shape. And that is exactly what we're going to do here today. If you made it to the challenge problem on Friday, this is going to be kind of similar. I just want to go through my thought process on a problem where there are multiple transformations. So we're going to have either, again, translations, rotations, and or reflections. And I just want to remind you guys that there are multiple ways to doing these problems. Not everyone will do the same steps in the same order. There's no one exact right answer, but there are definitely things that we want to think about, especially the properties that we know about each of the transformations. So I'll get started here. I'm going to map the orange figure onto the green figure, and you guys will have a chance to do this in some practice today, and hopefully this will be helpful. So the first thing I notice when I look at this orange figure and the green figure is that it looks like a reflection. So if I look at this orange point here, this corner, and this green point down here, I couldn't have just translated it, moved this from here to here, because this point would be moved over here, right? So this, I think that this figure got reflected mostly based on these outer points. I can see that if there were a line of reflection right here, it looks like this point and all points on the figures would be equidistant from that line of reflection. I also notice that it doesn't quite look like a rotation. So the way that I picture it is maybe a center of rotation in here. And if I rotated it counterclockwise, so this direction, these points here would still be pointing in the same direction. So they'd still be pointing to the left or up. So, we're refreshing GeoGebra. That's nice. Let's see if my file's still here. Oh, yep, still here. Okay, so sorry about that delay. The first thing I'm going to do is I'm going to grab my line tool and create that line of reflection that I think is there. And it appears to me, straight down the middle between the two objects. And straight down the middle seems kind of colloquial, but what I mean by that and what we recognize is that each of the points on this object, this figure, have to be equidistant to the line as these points on this figure. So straight down the middle means I'm splitting those points in half. So that equidistant characteristic. The other characteristic of a reflection is that if I drew a line between corresponding points, for example, this point and this point, it would create a perpendicular line. This line would perpendicularly bisect that segment. So anyway, that's a lot of words to say that I'm going to draw a line. Then I'm going to come up here to my transformation tools. This is where all of my transformation tools live. So the cool thing about GeoGebra is that while some of these mapping problems can seem really tricky at first, GeoGebra allows us to really experiment. If we were doing these by hand, it would take us all day. But GeoGebra allows us to try things out. If they don't work, excuse me, you delete it and start over. So reflect, rotate, translate. We've used all of these. So I'm going to do reflect about a line. So, and then remember that the gray box at the bottom tells you which order to click things in. So, and if I forget, I can go up here and highlight it again, and it says select object to reflect, and then the line of reflection. So I'm going to do just that. I'm going to select the orange polygon, and I'm going to select this line to reflect about. So I'm going to grab my move tool because it looks like I didn't get it quite right. So I'm going to start manipulating that line of reflection and see if I can get the orange figure to align with the green figure. And actually, just to keep track of things, I'm going to change the color of my reflected figure just so that we don't get it confused when I'm talking with this orange figure. So my reflected figure, I'm just going to make blue. That's arbitrary, but it's blue for now. So it looks like I can get it pretty close. And what I'm starting to notice is that these key outer points, like the distance and direction from here to here and here to here and this point to this point look about the same, which leads me to believe that maybe we have a translation on our hands if each of the points is moved by the same amount in the same direction. So I'm going to just zoom in to make life a little bit easier. So in order to test my translation hypothesis, I'm going to grab the vector tool because we need to translate by a vector. That's what translations are all about. So I'm going to grab that vector and I'm going to draw a vector between corresponding points. So this corner and this corner. I just chose those. It could be any of those corresponding points. It doesn't matter. And then I'm going to go back to my transformation toolbox, translate by vector. Again, remember when you're translating or doing any of these, if you want to move the figure, if you want to transform the figure, click inside of the figure or else you'll end up transforming just the edges or just a point. And then in the case of translations, you want to click on just the vector. So there we go, transformed. And again, just for clarity, I'm going to change the color of this transformed figure. If I can. Settings. So, there we go. Let's make it pink for fun. There we go. There's our pink figure. So maybe let's change this one. Oh, I think I changed the one underneath. So here we'll do brown, boring brown. All right. So there's my blue figure transformed onto the green figure. And you can kind of see the line of the green figure below, but I think we got it pretty darn close. Let's just zoom out and zoom around and see. A good point, really all of the points should be aligned if the figures are congruent. So side with side, point with point, that is the key. And I actually didn't mention it in the beginning, but we have to go into this problem. If I say map this figure onto this green figure down here, you have to know that those figures are congruent. So that means that all those sides and all the angles are the same. So once I get it correct, once I have the figure mapped onto another figure, see I'm off just a little bit there when I zoom out, but that much is user error. I can probably manipulate my reflection enough to get it close. See, from this vantage point, yeah, probably one on top of the other. There will come a time in a couple days, I think Wednesday, I'll ask the question, are the figures congruent? And when you do that, you will actually map one figure onto the other. And if you can't get it to map, no matter how hard you try, then you can conclude that those figures aren't congruent. So now, since I was able to map orange, so I reflected orange to blue and then translated blue to brown on top of our green figure. So that concludes our transformation. So we can say that we transformed the orange figure onto the green figure. Knowing that those are congruent figures, we use a reflection and a translation. So just to shift that out of the way a little bit, we can see our green figure underneath that we mapped onto. That's our original figure. So email me if you have any questions. I think that's all.